This meeting is being recorded.
The second section of Chapter 17 reviews nomenclature of benzene derivatives. So benzene is generally the parent when we have a monosubstituted derivative. So that's what we see below here. So all of these compounds have benzene listed as the parent, and then since there's only one substituent, we would just put that right out front of the word benzene. So this first compound, this is a chlorobenzene. Then we have a nitro substituent here. So this is now nitrobenzene in the middle. And our third compound has an ethyl substituent, so we would call this ethylbenzene. So again, this works well when we have only a mono-substituted benzene derivative. When we have other more complicated structures, sometimes we have to name a little differently. So we'll see that in a second. This slide shows some common names, and these are generally accepted by IUPAC as parent names. So whenever we have the benzene derivative toluene, we could use, or whenever we have a benzene ring with a methyl substituent, we could use the term toluene. When we have a hydroxyl substituent, we would call it a phenol, etc. So I would know all of these benzene derivatives and their common names, their common nomenclature. So now if the substituent is larger than the benzene ring, then that would become our parent chain because it's larger than 6 carbons. So we would have here phenyl as our substituent for the benzene ring. So this will be called a 1-phenylheptane. At times you also see benzene rings represented as pH, which is short for phenyl, or with a Phe symbol like this. So you can see various representations of these benzene rings depending on what compound you're looking at and how many substituents are being represented. This structure here, this is again a specific benzene derivative. This is a dimethylbenzene. So we have 2 substituents, and these are referred to as xylene. If we have both of these substituents next to one another in a 1,2 carbon fashion, this will be a 1,2 dimethylbenzene, or we could use the clarifier ortho to represent these 2 substituents' placements on the benzene ring. So this sometimes is abbreviated O. Then we have our meta-xylene here, where we have a 1,3 orientation of our dimethyl substituents. And then if we have a 1,4 orientation, this is referred to as para. So paraxylene or 1,4 dimethylbenzene. And we can use these as locations or descriptors, these terms ortho, meta, and para, to describe the location of these 2 substituents on our benzene ring, specifically in this case, the dimethyl substituents in xylene. So we not only use the ortho, meta, and para to describe the xylene, we can also use it with different substituents. So we can see here that we have an anisole parent, and then our nitro substituent here. So this nitro group is ortho to the substituent that makes this parent anisole.